I'm due to be talking with Geert in just a few days' time, and as such, I thought I would share with you some important basic premises that will help you understand what he's talking about. And essentially, I'm taking it from an important document that he shared, and I will get it up for you here about the immune Trojan horse. When the Trojan horse becomes the elephant in the room, hidden dynamics of vaccine associated viral immune escape in highly COVID-19 vaccinated populations. This is complex stuff. And he has shared the full document with me. He does have a summary, which I think you can get on his Voices for Science and Solidarity. But in order for you to understand what he's focused on, I think that I want you to grasp a little bit about the science of the immune system so that you can see where he's coming from. I'll make this nice and simple and make this nice and quick. So let's go through a few simple premises. I will just give me 1 second here. I'll just get my slides ready again. And here we go. When we look at the coronavirus structure, what you will notice is on the surface are the spike proteins in blue, and this is the viral envelope in gray, and you can see this spike protein stuck in it as well. And there are a few other proteins stuck in this envelope. These are the membrane proteins and the envelope proteins. And then inside, you have the viral RNA, and it is attached to these nucleocapsid proteins. Now, what has happened is that our focus has primarily been on the spike protein and the changes in the spike protein for the different variants. And what Geert is saying is that they're missing the big picture here. They're not realizing that there is a transition coming up in terms of how this virus is evolving that will make it make a jump similar to Omicron did from the other variants. And this is just an example again of the spike protein. And this is the front. This is where ACE2 normally binds. So that's the key to get into the cell. So this is the mechanism that the virus uses. Now, remember this. Everybody is focused on spike and the variations in spike, but Geert is talking about the nucleocapsid. So this is very important because when we think about how it occurs with the immune system, you'll realize why targeting the spike protein, which is on the outside, means that you can use antibodies because it will bind to the spike protein. But what happens if the immune target is on the inside? You need a different strategy. And this is just an example of all of the mutations on the spike protein for the one of the early BA2.86 mutations. Look at all these mutations scattered all around the spike protein. And this is what helped this variant to be able to evade the immune system. And it's continuing to develop these variants. And these are just random changes to the spike protein. And if one is able to infect better, that version of the virus will then propagate. So the next simple thing to get is the basics of the immune system, especially in relation to coronaviruses. It's what I call the COVID immune team. You have your monocytes or macrophages. Neutrophils are like the foot soldiers, the pawns. T cells, the Air Force. B cells are like the artillery. Natural killer cells are like the Navy, and you have mast cells. Now, the one that I want you to focus on primarily is the T cell. And part of the problem is when we describe it as one variation. It's much more complex than that. And I'll be linking these two together, but you will understand why this is important in the context of what Geert had been saying. What you have to realize is when a virus infects a cell, actually, we'll come to that in a little bit. Let's look at these critical T and B cells. Now, I've divided the T cells into two groups. Now, there are more than this, but in the context of what we're doing, making it simple, this is the CD8 T cell. This guy is like your Navy SEAL. He doesn't just go and shoot up the place, he destroys the building. So these cells will destroy, they're cytotoxic, they destroy infected cells. Very powerful in terms of getting rid of viral infections. Your B cells are like the artillery or the bullets for the gun, and the antibodies are able to shoot at a distance and get to virus wherever they are in the bloodstream. But who is this CD4 helper T cell? This is your general. This is the coordinator who is back in the office with the oversight of the whole battlefield. Very, very important cell, quietly operating in the background. And this is essentially how it works. So I'm going to break it down quite simply. And this will help you to understand when Geert starts to talk about T cells and so on, what he's making reference to. So here you have cytotoxic T cells versus B cells. Remember, these cells are like your Navy SEALs. If there is viral antigen on a cell, boom, it just destroys the whole cell, kills thousands of viral particles in the process. You know, this is a beast of an attack. On the other side, you have the B cells. These can produce thousands of antibodies, which will then bind to the virus, prevent it from infecting, and allow the immune system to pick things up. So you can imagine that this works when the virus is in, say, the bloodstream, exposed. This works if the virus gets inside a cell. Both of them are very important. What's happening is that this is no longer working because the virus is evading the antibodies. So the antibodies are no longer as effective. So you're left with your T cells. And so your cytotoxic T cell can still destroy cells that are infected. But this is where the but comes in. What is happening, and this is what Geert is saying, is that because the virus is changing the nuclear capsid, so it's not just a spike protein, it is gradually turning the nuclear capsid. And nuclear capsid doesn't usually change that much, but Geert is saying that it is under so much immune pressure that part of its strategy is to change literally the inside shape of the virus so that it can avoid the immune system. And here is the critical piece of the puzzle with this. This is this CD4 helper cell. And what these do is they coordinate the T cells and the B cells. Whenever things are happening, they are the ones that are picking up the relevant antigens. And what Geert has been saying is that these T cells are like the final piece of the puzzle when it comes to fighting off a completely evasive Hivicron variant. This is critical. This is really, really important. I really had to think about this looking through his document and saying, okay, where is he targeting? So this is what essentially he's predicting. What he's saying is that when the nuclear capsid changes some more, it will then evade how these helper cells work. So now these helper cells are still firing out cytokines and still stimulating the cytotoxic T cells to attack, still stimulating the B cells to try and produce antibodies, even though they may not be as effective. This is a critical piece of the puzzle. Without these cytokines, there is nothing left. There is no response. And what Geert has been saying is that if we have a variant where the nuclear capsid, because these ones are picking up the antigen on the inside of the virus, targeting the cells that are infected as well, suddenly there is no immune response left. And this is essentially what he has been saying. And just in a summary, what Geert is predicting, and we're going to hopefully talk about this on Saturday, he is predicting that there is going to be a variant because the virus, there is a gradual change to the nuclear capsid. And just in case you are late, when we talk about the nuclear capsid protein, we're talking about this on the inside of the cell. We have always been focused on the spike on the outside. What he's saying is that this, which doesn't usually change, is gradually shifting so that it will evade the T helper cell response. And when that happens, there is no protection left. And this is essentially what he has been predicting for some time. But as he said, it took a long time to try and piece it together. Here is his point. He says the genomic surveillance often misattributes their rapid spread to minor mutations in more routinely analyzed spike protein, obscuring the role of cytokine-related immune escape. And the cytokine is from the CD4 helper cells, and this seems to be where he is predicting this is going. The problem is that when I've pulled back from that and I've done the Hivicron's course recently, looking at what were the outcomes, one of the things that comes is that if you have a variant that has so evaded the immune system that there is literally no immune response when someone is infected, they don't even get fatigue and they don't even get a headache, they're not producing any interferon, they're not producing anything. The virus will then continue to replicate, infecting cells, especially in the blood vessels, and just keep on replicating. And then suddenly people get sick and you can't pull them back. And this is the kind of picture that he's talking about. I realize when we look at it and look at the pressure that is occurring with the high amounts of infections, sadly, he may be right. I keep hoping that he is wrong. But the more that I see, the more that I study, the more I realize this is probably the disaster that he's been predicting. And as they say sometimes, what he has said, it's easier to ignore. The question is, what would we do, or what will we do when that eventually occurs? Thank you very much for listening, and look out for our presentation coming up this Saturday with Geert, as we talk about and analyze his recent document and his thoughts as he is sharing at this point. Have a great evening.
A hero, an immune adventure. Humming Heroes, your lyrical guide to the body's defenders. Now on Amazon. Check the links below.